Sup guys, welcome to today's show. So we're gonna start by trying to fix the broken destroy tokens function, or macro rather. And I think I might know what's wrong. I think the problem is I used the same variable name here as in the body of the function. So let's see, we will open up a do block. And let's see if I remember how I did this. We had an int 16 n. And then we had a for loop. So for, and we'll set n to 0. We're going to loop as long as n is less than, and this would be x dot length. And then n plus plus. Right. And at every iteration, what are we going to do? We're going to call destroy token. And we want to give this the x dot t's and this number. And when that is done, we want to free our x dot t's as well. And let's not forget all these backslashes. And at the end, we'll just do while false. Like so. Alright, let's see if this works better. This is another error message than we got the last time. What if we were to do something like this instead? So let's see. We want to get it. Sorry. We want to get it x dot t's plus n. What if we just do that? It compiles. No, it still does not like this. I wonder why this does not work, because all of these t's are individually allocated, because make token and all of this, its derivatives, it allocates this. Oh, wait a second. The pointer is hidden inside of here, right? HTML contents start is equal to P. That is what we're gonna destroy. So let's do that. So instead we do x dot t's, and then we do n. So this is the token. Then we want to get at the contents, and here it differs between the different types of tokens. But they should all have the same position. So what if we just use that? So if we create an additional parentheses and we take the address of this, can we do that? Seems like. But it still complains that it's an invalid pointer. Because we want to get at these. These are the pointers we want to remove, so to speak. But we don't want the address of this. We want the contents of this. But can we really do this? I'm not sure we can. No. What if we cast it to a void star? No. What if we were to assume that all of them are text tokens, for example? Because if they were, we could just do content dot text token, like this. And what if we were to cast it to a text star? Because it should be able to free it the same way, no matter what kind, right? Or what type. It compiles. Double free. Why do they have the same address? It does not make sense. Contents, text token. That's weird. Let's code something that tries to check that. So let's comment this out for now, and let's do something like, well, we can do basically the same thing. We make a for loop, set n to 0, we loop as long as this is less than t's dot length, and n plus plus, and then we do something like this. Let's also put in the index. And this should be an unsigned int of t's dot t's dot contents dot contents. Text token. And we need to let's try this. While false, like so. Let's see what we get. We got disconnected. All right. Fortunately, Sociopath is very resilient. If we just reconnect, it should be fine. Didn't I save? Oh, I need to save again, that's right. T's is a pointer. So why doesn't that complain about that in the other occasion. Oh, let's put in the index as well. And what do we get? The same address. Why is that? Is this one of the mallocs? Let's see. Okay, this time we got another address. So, malloc, malloc, malloc. $51B0. It's this one. And why do we get that in every position? Oh, wait a second. This is a static variable. So it does not remember the other addresses. Okay, that's the problem. Okay. Do you really need to malloc this as well? And if we do, how do we store that? But why does this work if that's the case? Because we save them here. Well, you guys, I believe we need to create a real garbage collector. At least a simple enough version. Okie dokes. So let's start by defining some structure. Let's call it garbage. And let's make this a dynamic array. So what we'll have in here is a pointer p. Now we need to have an array of pointers. So let's do a double star then. And let's define the capacity. And let's define the size. So this is the garbage. Let's create a constructor for this thing. So we'll do garbage, make garbage. We don't need to have anything in here. Let's also make a definition. What should we call it? Garbage collector block size, perhaps. Not entirely accurate, but good enough. Did I make it a pointer? Yeah. So we'll start by calculating the size. Which will be the size of struct as garbage times garbage collector block size. Then we allocate this. And we need to set the fields as well. So the P will be equal to void double star 0. The P capacity will be equal to the block size, and the P size will be 0. And then we return this. So that's a constructor. We need a function to add stuff to it as well. Let's call it add GC. And it takes a void star. So void star pointer. First we need to assert that we have a pointer. Well, we need to give the argument of the garbage. So if our garbage size is more or equal to the garbage capacity, then we need to make this bigger. Then we need to have a size so the new size should be the size of struct s garbage times the capacity plus the block size. So we increase by 1024. So then we'll do a realloc. And we give the P and we give, no, not the P, the G. And we give the size. We assert that we have a P. This should be G and pointer. And then we can continue with our business. We also need to update the capacity. So P, let's not use P, by the way. It's easier to just modify this thing. So the capacity will be equal to the old capacity. Okay, so we can do plus equals GC block size. So now we will have room for adding this thing. And the current size is the index we want to get at. So the GP of G size will be equal to our pointer, and then we will just increase the size. Simple enough. So now we can add. Now we also need to do the actual garbage collection. So we need a function. Let's just call it GC for garbage collection, and we give the garbage. So void GC, and we have garbage G. And what are we going to do? Well, we need to have an N. And we'll need to do a for loop where we set N equal to the G size minus 1. And as long as we have an N, we're going to keep on looping, and we're going to decrease this. And at each iteration, we'll simply do free P GP of N and then we're going to free the whole thing. And we need to have another of those, because when we have freed it, we need to create a new one. So we'll make garbage, and we'll return the P. So this can't be a void anymore, because we need to return the new garbage. Like so. And let's update this as well. Garbage star. And we either need to give this garbage collector to every make token call. Yeah, I think we're going to do that actually. So garbage garbs equal to make garbage, and we'll give it here garb. So we need to update the signature of this. Make token. So here We need to have the garbage. Let's see. Now we can't simply do this any longer. We need to do something like token ret, and we'll set ret equal to this. So before we return this thing, we need to grab that pointer. So basically we need to do similar to this. So our pointer will be equal to the return contents. Let's just pick one of those. I think we can do this without a cast. But how do we update the garbage? Do we need to return that as well, or can we cheat and make it a global variable? Wait a second, there's a second option, isn't it? We can send the actual reference. And then we can just do well, it's gonna be G equals add GC, G pointer, I suppose. And then we'll just return the ret. I think this is gonna work if we modify this slightly and do this. And down here we can simply do gcg. Let's see what the compiler says about this. Void value not ignored as it ought to be. LGC. We made this a void. Okay. So we need to do the same thing here then. We need to do this. Incompatible pointer type. Garbage. Double star. Maybe we don't need to do that. I almost never use function parameters as output variables, so I'm not very used to this kind of stuff. But we'll figure it out. Okay. P undeclared 299. Yeah, it should be G. G undeclared 354. I think we call it garb here. Okay, it compiled. Let's brace for impact. I did not see that coming. Ret is 0. We switch on the type. Now we need to break. Before we had return here, so we didn't need the breaks, but we do now. Okay, let's try again. Segmentation fault. At least something new, right? And where does it crash? It checks the string length of TML. So basically we go to the make tag start. So it's probably this add GC that crashes then. And what do we do in the add GC? If G size is more or equal to the capacity, which it shouldn't be. So these two things is all it should do. Did we initialize this thing? Yeah, we make the garbage. And we send it to the functions. It's weird that it shows this string length, but we're not using that function. We are using our own string length. It must be this add GC that fails. Let's just try to comment it out temporarily. Yeah, now it crashes when it tries to do the garbage collection. But it's a very simple function. G P G size Before we do this, let's print the size and the capacity of this thing. So we have the G size and we have the G capacity. Size 0, cap 1024. So this is GP0 is equal to the pointer. And that's a crash, I suppose. So if we do an exit 0 right here, it still crashes. Does not. Yeah. Oh, wait a minute. I thought about this wrong. We shouldn't make it like this. We should make it like this and move it down here. If it's possible to do that. Let's see if it is. Uh, 285. All right. So this should just be PP is equal to P arrow P is equal to 0. Let's do this. Maybe this. All right, it compiled. And it did not crash. 0, 1, 2, 3, 4, 5. Does it do the freeze? Yes, it does. All right, you guys, we have successfully completed a garbage collector. Easy as pie. Yeah, I think that's it for this session. Thanks for watching. Thanks for today.